Where's the problem? We have a square and we have 6s. So we will take the s square equals 6s alone. It looks like a square plus ab or a square minus ab.
Square must be.
Oh, what's a and what's b? A is s and b is 6. So let's put the formula for it. A is s plus b over 2 minus b over 2. Miss, if you are used to complete the square in another way, do it. For me, I do it in another way. This one as a formula, it's easier for you to deal with. So do any method or any method that you know or feel comfortable to complete the square. Okay, miss, what will we get here? S complete square minus 9. Right, miss? Okay. Now this one, it will be Laplace inverse 1 over x plus 3 squared minus 9 plus 10 is plus 1. This shape now, are you okay with it?
Sine theta.
Okay.
Plus y plus 1?
What's what?
Y plus 1?
Minus 10, minus 9 plus 10. Now this one, if we don't have the 3, are you okay with it?
Yes.
What will be without 3?
Sine.
Sine. And because we have the 3, it means that A equal.
Minus.
So we will multiply by.
Negative 9.
Negative 9 plus 10. You already have plus 10. Any questions, miss? Did you finish writing from the board? Questions? What I need from you now to do is just to copy part A. Laplace inverse of 2s plus 5 over s minus 3 squared, and we will do it. So we need to find Laplace inverse of 2s plus 5, right? Over
Minus theta.
s minus 3 squared. Let's go back to partial fraction. We have 3 cases, and previously we considered only 2 cases of them. We have the stick roots or we have irreducible factors. Yes. Now, if we have this one, p at, let's say, over x minus a power n, and of course degree of pH less than, and of course and the possible. This one, how do we divide them? A1 over X minus A plus A2 over X minus A squared plus then we reach A X minus A squared. This one is calculus. Okay, write the formula and apply it for the other exercise that the previous exercise that we wrote. AIs are constants to be determined. Okay. Here what we have 2x plus 5x minus 3 squared. Compare it to the previous one. How will we apply the formula for partial fraction? It's equal to what? A over
This one.
plus
And
B over S minus 3 squared. Can we find A and B? Miss, again, when we have this one, we can find the answer in terms of A and B, and at the end we find A. It will be easier. So we can find the answer now in terms of A and B, and then we will find the values of A and B. So this one is that we will write A over S minus 3 plus B over S minus 3. So find the answer now in terms of A and B, and then we will evaluate A and B. Each one this way, Miss.
yes.
Addition, scalar multiplication, and it's linear, we can separate. The first one already, it's from the table as well. From the table, this one is as well, Miss.
Usually.
8 power 3 doesn't mean 240. But this one is, if we remove the negative 3, what will we get? 1 over S squared. What's 1 over S squared? B T, right? And we will multiply it by 1 E3. Now, what's our A? Find AE, they are equal to what? Also, when we are using partial fraction, don't waste your time at the very beginning finding A and B because you will forget the answer. Put the answer in terms of A and B, which is the main important thing in our objective, and then we will find A and B at the end. Okay, miss, we need to find A and B. So go back to this one. Do common denominator and get A and B. So we need now the last step is finding A and B. Please start with this one. Are we finding it, miss? I will be right here. I will wait the answer from you. Our aim is to find A and B, so we need to do common denominator and then compare the numerators together. How do we do common denominator, miss? What's left for the first to be x minus 3 squared? We should multiply it by x minus 2. And this one is 2 and 5 over x minus 3 squared. Now they have common denominator in both of them. It means that their numerator should be what? Their numerator is equal to each other. So what will we get? So x 5 expand ax minus 3a plus b. Now let's the coefficient of and the coefficient of the constant. What's the coefficient of x in the left hand side? And the coefficient of the constant in the left hand side? Okay. On the right hand side, a is, and here what do we put? Solve the system. Does it need calculator?
No.
So immediately a equal and b is equal 5 minus 3 to 2, which is negative. So we got a equal 2 and b equal negative. We'll go to our previous part. Is Johnny?
Is it?
Minus 3a, we are bringing, so this is minus 3a.
Plus 3.
Yes. So b is equal 5 plus, and we will get here 11. Now we will go to our previous answer and just put instead of a its value and instead of b its value. Any question? You finished writing from the board, Miss? What I'm going to now do is to think about part B. Please, each two together, let's take 3-4 minutes to focus. So we need to do now part B. We are done with part B. we did something, an example about like this one, right? Didn't we miss? What's the first step? Where's our problem list? We solved first our problem in the denominator. You still remember? The problem in the denominator is s squared plus 4s plus 6. So it's not s only. So it's like a combination. I need to, what do we need to do as we did? Complete square. Perfect. How will we complete the square? S squared plus 4s is equal to 1. How did we write it? So please, all of you complete the square now. Okay, s squared plus 4. 4. So we should get s plus 2 squared minus 4 plus 6. So plus what? So this one, s squared plus 4s plus 6, we should get s plus 2 squared plus 2, right? Now the denominator is perfect. Now where's the problem? Numerator. Okay? So this s, the constant alone, we don't have problem. Where's our problem? The s. Instead of s, because down we have s plus 2, up what should we have? S plus 2. Okay, based on this discussion, please now continue this one. Let me solve it, miss. Okay. What did I answer? For answers, miss? So we wrote this one, we have s over 2 plus 5 over 3. Now we solve a problem in the denominator. Where's our problem? In the numerator. S over 2, we need plus 2 in it. When you add to s plus 2, you will subtract also minus. So what will be get, miss? We will subtract and add. When you subtract, you should add as well. So we should all get this answer. Please check if you get the same answers. If not, please raise your hand to discuss. Do we have any questions so far? Okay. Now, miss, what I need from you to do is to write this question, and I expect that all of us are able to do the reverse one, which is the last result. So here, of course, I should add here that t is greater than or equal to 0. Let's just like discuss this question. What's the order of this differential equation? Second order. Is it linear? T is greater than or equal to 0. Is it initial value problem? How many initial conditions did they give to us? 2. They are enough because it's second order. The initial conditions are given as 0 or not, miss? Okay. So are we able to apply Laplace? Okay. Miss, just to make sure that everything regarding the previous factor is okay. First step when we reach Laplace and get something equal something, collecting the y, I expect that all of us are able to do it. If we did not attend last lecture, please do it with a colleague and raise your hand if you face any problem. Please write the question. Just in your natural breath. But if one of you has a problem, like 3 times in a day or something, I can just change your day. So just let me know before. After brightness. I know that some of you have midterms, so you will not have time to practice at home. So instead of that, we will practice here and we will go through the material. Yes. The first step, which step did we reach? So step number one, Laplace transform both sides, right? What should we write? Laplace y, we will like capital Y. Do we need Laplace y prime and y liquid prime? Do we need them now? Okay, what's Laplace of y prime? Y minus y0. And Laplace of y liquid prime? Okay, that's y0 minus y prime 0. We cannot keep them in this way. We need to put the answer, right? So x of y minus 2 and here, x squared y minus 2x minus 7. This step, all of us did it, miss? We reach first. Which step did we reach here? You reach the capital Y equal to what? Okay, so how will we start now? Laplace of the left-hand side, which is y at the prime minus 6y prime plus 9y equal Laplace of t squared e3. So Laplace of the left equal Laplace of the right. This one that is here, t squared becomes 1 or 2 factorial, 2 over s cubed, right? But what do we have here? A is what? Okay, this is the right hand side. We applied the first translation formula. Now the left hand side is what? Laplace of y double prime. We will put x squared y minus 2x minus 2x only, right? Minus 70. And minus 2 at minus 70. And 6y prime fy minus 2. And this one plus 9
Plus 9.
capital Y. Right, miss? The next step, collect the y's together. What will we get? X squared minus x plus 9. And bring the other one to the other side. We'll get 2 over minus 3 cubed. This one, it becomes plus x. Here we have plus 12 minus 17 minus 5. So it will be 2x plus 1.
Can I get 2 over s minus 3?
Yes. This one t squared, what's the plus of it?
2 over s squared.
Okay. And here what do we have? E80. E80 means that A is equal to what? To 3.
3.
So f of s is 2 over s cubed. F of s minus A, instead of s, put s minus 3. Okay. Did all of us get this answer? All of us get this one, miss? Now we need y alone, right? So what's y?
Of S minus A. G.
Can we do common denominator here? 2 2x plus 5 into x minus 3, right, miss?
You know, this square minus.
Didn't I write it wrong?
Can't you write S square minus 6?
So this is why we are done with the first step. Of course, we can simplify it or write it in a simpler form, but at this moment we are done with step number 1. In order to apply step number 2, which is even first class, we need to rewrite this one in a simpler form. Now, let's binomial function. Even if you forget the formulas, that's okay. You can write it as a minus b squared into a minus b and famous.
Complete square first or small first?
Mhm.
We'll do the complete square first or small first?
Do we really need complete square? Look at oneness. Okay. Can we write y as y equal to 2 plus 2x? Right? We can expand this oneness s cube minus 3s squared minus 9s squared minus plus 3 times s times 9, which is 27, s minus 3 cube, which is negative 27, over s minus 3 cube. Can we write this one s squared minus 6s plus 9? Isn't it s minus 3 squared? Isn't it this s minus 3 squared? So what did we get y at? The numerator, I will write this down. Minus 3 over 5. Now, what's y? We wrote it in its simplest form, so y is equal Laplace inverse of capital Y. This is the next step. Now we have this one. Y is equal to what? The numerator, the degree of the numerator is 4. The degree of the denominator is 5. We can apply partial fraction. How can we apply partial fraction? A1 over s minus 3, right? We wrote the formula. Plus A2, or if you want to write it A, B, C, A plus B over s minus 3 squared plus C over s minus 3 cube plus B over minus 3 4 plus E over s minus 3 power 5. Right, miss? Didn't we write this one?
Yes.
Okay. Now, what would be y? Don't put A, B, C, D, E at this moment, okay? If you want to find it, we will get 5 equations with 5 unknowns. Each of these, it will be A, Laplace inverse 1 over s minus 3, right? Plus B, Laplace inverse 1 over s minus 3 squared, plus C, Laplace 1 over s minus 3 cubed, plus E, Laplace inverse 1 over s minus 3 times 4 plus E Laplace inverse 1 over s minus 3 times 4. I'll be able to find each of them alone now. Are you able to miss? So 1 over s minus 3, it's from the formula in the last one, right? A e powers 3t. Now these ones remind us of what? If we don't have the minus 3, what will we get? 1 over s squared. What's 1 over s squared? 10t, right? Right? So I multiply it by e3. The second one, minus 3 cubed, it's what? If we remove 1 over s cubed, miss, it's what? Please go back to the previous formulas. 1 over s cubed. T squared over 2 factorial, and we will multiply by and 1 over s squared means P3 over 3 factorial, and here P3 and 1 over s5 for you. And it's unplugged.
E over
E power 3t, right?
E over product.
The same D over
E.
oh, this one E you mean the last one. The capital E. Because of the stuff. Do we have any questions, please? Now, to make sure that everything is clear, we will do more example. You will start with it in pairs, and then we will talk about the next steps. It's 5 equations with variables. The A now is not partial. I know that you are able to do the partial. In case I wanted to bring, let's say, 5 equations with 5 unknowns, I will make sure that it's easy. If not, I will give you some hints, the values of them, or I will ask you just to find them without evaluating the option. Okay. Of course, if the options are only 3 or 4, we are able to find and to solve 3 and 4 in class. Okay, so do we have any questions? We start with this one. Part as the possible sites. The first step, we reach capital Y equals something. I expect that all of us, you are feeling that it's easy to do it. Because it's straightforward.
So.
Yeah. But miss, we have to start as y equal Laplace of what? Then substitute. And that can be what's Laplace of y prime, what's Laplace of y double. So Laplace of y prime would write. And Laplace of y double prime would completely word and write Laplace of y prime. Write Laplace of y prime and y double prime in the word. One over s plus e minus at, e at is 1 over s minus a. So e minus dA is negative minus. Here it is. Okay. And s square y minus f y 0 minus y prime 0. Y 0 and y prime 0 are zeros. They are given as zeros, so it will be the answer. You cannot leave it in the exam this way. You have to put the answer by using these ones. So now, what will be the answer? F capital Y, and down we will have F squared Y. Okay, you cannot just start immediately F squared Y and these ones. You have to tell me what you're doing. So now, what will you say? Laplace transform both sides. Okay, miss? Laplace of the left equal Laplace of the right. Are you okay with that now? Okay, what's the next step? So we would write here Laplace of the left equal Laplace of the right. The right was 1 plus e, and the left was y double prime plus 4 prime y prime plus 6 1. Okay, miss? This one f squared y plus what was it? 4sy this one. And this one was the capital what? The capital what? Okay, and this one plus square. Okay. What's the next step? Collect this. We take y, but this y you wrote it wrong, miss. Y should be capital letter. So we will collect the y now, which is a function in s, capital letter y. So y into s squared plus 4x plus 6 equal 1 over x plus 1 over s plus 1. Now this one, miss, it's easier to make it common denominator. Can we do the common denominator here? Okay, s plus 1 plus s, so I will get 2s plus 1 over s into s plus 1. This part, did we reach it, yes, miss?
It's a plus or minus?
Which one minus?
Yeah, for us.
It was 4 plus 4y, right? So plus. Now what I need from you to do is to write y explicitly in terms of s. Do not evaluate the coefficients of partial fraction from the beginning. Keep them always to the end. Write the answer in terms of t, and then we find A, B, C. After you finish solving all questions, find these values. Because these values, they will not have that much points. The points are on the solving. So don't waste your time solving it. keep it till the end. Okay, what's y now, man? Y is equal to 2x plus 1 x into x plus 1, and here x squared plus 4x plus 6 it was, right, miss?
Yes.
We put it in a box because it's the simplest form that we can get. Why? Can we factorize x squared plus 4x into 6? It's what? Reduce. How do we know that it's reducible if we forgot? You will put it on the calculator, you will get complex roots, okay? So it's reducible over the set of real numbers. Now, our aim is to apply the inverse Laplace. So y is Laplace inverse of y. This one that is here, miss, it's equal to what? You have a factor s. I'm okay with the factor s, right?
Yes.
So our problem is in the denominator. Numerator, whether I have a problem or not, I don't care about it at this moment. I solve the problem of the denominator and then I will move to the numerator. So I have x, we don't have problems in the x. I have x plus 1, we have problems in the x plus 1. And this one is irreducible. It's the same, but this one, we do have problems in it, we will try to solve. This one, what we put, linear factor A, linear factor B. Factor according to the x plus. Okay, miss? We are applying now Laplace. So y is equal to A Laplace 1 over x plus B Laplace 1 over x plus 1. And at this moment, I would write Laplace inverse of Cx plus D over square plus 4x plus 6. The only one that needs work is this one. Okay, miss? Now, the first one, this one, what's the Laplace of it? 1 multiplied by A. And this one, e power negative t. What do we need only? Ts plus d over s squared plus 4s plus 6. This one, we still have a problem with the denominator, but already we solved something like it, right? So we need to complete the square. This one, we completed the square for it, right? After completing the square, what did we get? S plus 2 squared plus 2. And up, what do we have? Cs plus. This one, we solved it exactly the same. The problem with the denominator is gone. But where's our problem now? We cannot have s plus 2 down and s up. So the s that is here, the s that is here, we need to separate it as plus 2 minus. Why did I choose plus 2? Because down what do we have? If I have s minus 2 down, I will put s minus 2 plus 2. Okay, please think about this one. What will we get now? C is plus 2 minus 2c plus d over x plus 2 squared plus, do we agree? what will we get, miss? Equal to C into X plus 2 over X plus 2 squared. We will get Laplace inverse of Cx plus D over S squared plus 4x plus 6 equal to Laplace inverse of C into S plus 2 over S squared plus 2 plus Laplace inverse of minus 2C plus D over S plus squared plus. Do we agree, miss? Okay, miss. Now, do we still have problems? This one, X plus 2. If we remove the 2, what will we get? Sine 2t multiplied by a minus 2t. I have x plus 2, so what's a?
I think the value.
We have x plus 2, so what's a? A radical 2. We have plus 2, so what's a? Minus. And the second one, plus negative 2t plus b, we will have e minus 2t sine t radical 2, and we will divide by radical. Now, what's the last step? And this one, after we finish all the questions solving, we will find it. Do we have any questions? Not finish. Just sharing it so that I don't forget. Did we finish writing from the board? So again, the last step is we need to find A, B, C, D. From where do we find A, B, C, D in this? We will go here to common denominator, compare the numerators together. Polynomials to be equal, it means that they have equal coefficients. Any question? Let's go back to our outline. So what we are done with now, we are done with translation formula 1, the Laplace of it, and the inverse Laplace of it, and we applied it to the orbits. What's still in this section?
Yeah.
We still have the translation formula. So our aim is we have this one to solve Laplace inverse of these ones. Okay, we have something in S multiplied by E2S or E negative 3S. So this one, it needs a formula. This formula, it depends on something known as unit step function. When we hear the word step function, what do we mean by step function? Step, it reminds us of what we are doing step. Usually the steps we do it in this way. So it's like the stairs that we have here. We can imagine it as step function. So when we have a step function, the unit step function is given as 0 and 1. For example, if t is less than a, it's 0. If t greater than a, it's what? 1. This is what we call it unit step function. Unit in math means that. Now, what's required from us? For our next lecture, you will be explaining for me this part. So what I need from you to do is to prepare this part from here, unit step function. What do we mean by it? It's written, everything is clear. The formula for it, have your sum solve exercises, and we will apply it to a differential equation. We will do this one hopefully in our next lecture. I will give you time to prepare it. Of course, you need to go through it during the at home in order to be able to cover it. We will discuss and we'll solve all of it. Okay, I will do an announcement on that. Do we have questions, Miss? Any questions? Okay, so we know what to do. The file is on Teams. You can access it from Teams and you can access it also from live. Okay, let's take care and see.